Hi there, it's Andrew Dunkley from Space Nuts. Here we go again with a Q&A episode. I hope you're well. Thanks for joining us once again. And on this episode, we are going to be answering questions about dark matter and dark energy. However, the twist on this is, how do we predict movement in our solar system without accounting for dark energy and dark matter? That's a good question. Interferometry. Somebody wants to know if we can use space telescopes for that, and they're also asking about the life of Brian. We'll get into that shortly. Gravitons and whether or not they are responsible for gravitational waves and biblical floods. That's all coming up on a Q&A edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us once again is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Good to see you.
Good to see you too. And the voice is still struggling, so please forgive me. I might sound like a famous newsreader if I keep at it. But anyway, yes, I can bung it on at the moment, but hopefully it'll go away real soon. Shall we get started? We've got a lot to get through, so we've got a couple of text questions, a couple of audio questions. I think we'll just plunge on in. Our first question comes from Trent. Hello from St. John's, Newfoundland, Canada. It's my understanding the existence of dark matter and dark energy first became necessary to explain why stars at the edges of galaxies are unable to escape the gravity of the galaxy they live in. However, the existence of dark energy and dark matter is not necessary to accurately predict the relationships between the bodies in our own solar system. If dark energy and dark matter make up 96% of the universe, why is it not necessary to predict the relationships between the planets, moons, etc. in our solar system? Is its existence kept to a minimum within the bubble that is our solar system? Also, I have a question for Andrew. Is Hugh a real person? If so, why don't you have him on sometime? I love the podcast. Please don't stop making it. Love you guys. Love you too, Trent. I'll answer the second question first. Yes, Hugh is a real person. There he is there. Look, I can't you see him? Hang on.
Hello, my name is Hugh. It is good to be a part of the show.
No, he's real. He is real. He runs the whole company, actually. And he's been with us since the very beginning. And, he just sits there. And yes, look, we have asked him to come on the show, and he declines. Can't, look, he's an old radio man from way back. I actually met Hugh at a radio station in Newcastle when I was in high school and did job experience. This is a true story. I'd written him a letter asking him how to get in radio, and he never answered me. And I confronted him on that when I was doing job experience, and he said, "Oh, well, too bad." And I thought, "Oh, you're not very nice." Anyway, he ended up becoming my boss at the ABC, and here we are now working together on this podcast. I mean, it's a crazy world, the way it all works out. I saved that story up because he didn't remember me, but I recognised him and finally put two and two together the first time I saw him coming up the driveway at the radio station in Dubbo here. And I went, oh my gosh, I know who that is. And it all sort of unfolded from there. But I saved the story until the day I left the ABC, and I emailed Hugh and said, guess what? And told him that story. Yeah. So yes, he is real. He is real. Whether or not he'll ever come on the show remains to be seen, but put enough pressure on and you just never know your luck. Lovely bloke, and we really appreciate him. And I won't say anything nice about him ever again. Now, let's try and tackle Trent's question about dark energy, dark matter, and why it doesn't influence the movements of our planets within our solar system, given the fact that dark energy and dark matter make up 96% of the universe, or thereabouts.
Yeah, they're great questions. And it sort of comes about in terms of matters of scale, if I can put it that way. So dark energy is something whose existence only becomes apparent when you're looking at things which are millions of light years away. And it's its effect is to cause the expansion of the universe to accelerate. Neither that expansion nor its acceleration are prominent on scales that are small enough to think about planets and stars, or even galaxies, actually. So, our galaxy is not being torn apart because of the expansion of the universe, and that's because gravity is by far the most significant force over that kind of scale length. When it comes to dark matter, that is an interesting one. And basically, the solar system is immersed in dark matter. It's in a blob of dark matter, which is kind of the size of the galaxy. And so it is on scales relating to planets, it is perfectly uniform. And so it doesn't have any gravitational influence. We're sort of inside it, this uniform volume of dark matter. So even though it outweighs normal matter, when you look at the sum totals, when you look at the way objects in the solar system behave, it's simply the gravitational pull of the objects themselves that become important. That background, if I can put it that way, of dark matter is irrelevant because it's completely uniform. So it's, but they're interesting questions, and the existence of dark matter and dark energy is not just because we see galaxies that would tear themselves apart if there was nothing there other than what you can see. Galaxy clusters are the same. They would fly apart if all you could see was all that there is. It's not just those that tell us about the existence of dark matter. We've got gravitational lensing effects which come from dark matter. And we can look at the universe as a whole. We were talking in the last episode about the Anglo-Australian telescope and the way it's mapped the galaxies around it. The structure of material within those galaxies also tell you about dark energy and dark matter. In the science of cosmology, it's quite complicated stuff, but it actually reveals that both of them are real phenomena. And so it is still a mystery. It's still the biggest mystery that we confront, I think, in exploring the universe, with the exception of, are we alone? That's an even bigger one. Dark matter and dark energy, pretty good.
Yeah, and a lot of work being done to try and unravel the mystery, but so far we get more questions than answers. But one day we'll figure it out, hopefully sooner rather than later, but you just never know. We may never find out. Hopefully that won't be the case, but there's so much to learn. Thank you, Trent. Great question, as always. Our next question comes from sunny Queensland, I think.
Hello, Fred and Andrew. It's Bo here from Melbourne. You have the shortest name in your listener audience. I have a question for you. It's a theoretical one. I was wondering if it's theoretically possible to do interferometry with the space telescopes and ground-based telescopes. So we have the Hubble telescope, we have the James Webb, and we have a number of large ground-based telescopes. Can we actually do an interferometry imaging of a large faraway object using these objects, using these telescopes? That's how we got the center of the black hole in Sagittarius A star, and I think we can do something similar with those two space telescopes and a number of the ground-based telescopes. I was wondering if that's theoretically possible. Speaking of theories, has anybody done a study between the correlation of the name Brian and astronomy? I'll give you 4 data points. There's Brian May, Brian Cox, Brian Schmidt, and Brian Green. Surely they are not coincidences. Anyway, looking forward to your response.
Thanks, Bo. There's also Brian from sunny Queensland. Sorry, Bo, I don't know why I thought you were from Queensland. Maybe because I've got friends visiting from Queensland at the moment. Queensland's stuck in my head, but no, you're from sunless Victoria. So yes, thanks for Thanks for the question. Bo, what did he say? The shortest name in our listening audience? You'd have to be careful because, admitting that your name is B.O. is probably not the safest bet in the world. You could get ridiculed for that one, Bo. But thanks very much for the question. Let's go with the Brian angle first, Fred. Brian's in astronomy. I love this.
Yeah, there's a
bunch.
Former director of the Australian Astronomical Observatory, Brian Boyle, now resident in New Zealand. Hello, Brian. If you're listening, I don't think he does, but if he does, that's where he is. But you could say the same for Fred, because Fred Hoyle, Fred Kepler? No, I made that up.
I've got one. Freddie Mercury.
Oh, there you go, Freddie Mercury. Yeah, no, it's not far off, is it? Brian May and Freddie Mercury, like that they were.
There you are.
There are a lot of. It's quite interesting. There are a lot of astronomers with Fred as their middle name, including David Merlin, actually, David Frederick Merlin. And there were other Fredericks too. So I suspect there's not a link that you can make. I think a more interesting one is not to do with names, but I do remember many years ago when the old Siding Spring Lodge still existed, the one that burnt down in the Wombalong fire in 2013. We used to have evening dinners there for all the astronomers who were on the mountain because they were staying at the lodge. They used to have a dinner every evening, and conversations at those dinners were where many collaborations were dreamed up. It was quite extraordinary. So sometimes there were 20 astronomers around the table. I do remember one time sitting there and all of the astronomers on one side of the table, everyone was eating soup. All of them on one side of the table were left-handed.
Are you kidding?
Yeah, and I thought, surely that's telling us something about astronomers and the way their brains are wired. Because I'm left-handed too. So
maybe all the Freds were left-handed and all the Bryans were right-handed.
Were right-handed, yes. Could be it. Anyway, so curious collaboration. Curious correlation. Coincidence. What I'm looking for. Yeah. Regarding interferometry, let's come back to that for a minute, even though we're talking about space. With current technology, it's not possible, and that is, given that you can combine, 8 radio observatories to make the EHT, the Event Horizon Telescope, all facing one side of the Earth. They were all linked together by very accurate timing. The clocks were the vital part of that, and that's because in radio astronomy the frequencies are low enough that you can actually you can interrogate the phase of the wave that's coming in. So a wave coming in has a phase, and that means you can concentrate on one particular or determine which part of the wave you're looking at, a high bit or a low bit or whatever. Now, you can do that in radio astronomy. The frequencies are low enough that you can actually analyze those phases as they're going through, and then you can mix them later in such a way that the phases actually add or subtract from the different telescopes that you're looking at around the world. And that's the whole... that's the whole, not the raison d'etre, but it's very much the mode of operation of radio telescopes. They all operate, with the exception of single dishes, all the arrays operate on that principle of being able to know what phase your signal is at and then add or subtract at that instant the other ones to form an interferometer, which lets you measure very small angles and identify detail on very small scales. The reason why you can't do that with optical astronomy is simply that the frequencies are too high. There is no technology at the moment that can sample the frequencies of light waves in a way that will be reliable enough to add, the signal coming from, say, the Hubble telescope or the James Webb telescope. It may not be far away, though, that we do have that technology, because I've seen papers on the use of what's called heterodyne methods, which are what are used in radio astronomy. trying to apply those to optical signals, even though the frequencies are very high, it's very challenging. But it may one day be possible. It's not at the moment, but it's an interesting idea. And a nice suggestion, Bo.
Yes, indeed. Thank you, Bo, and good luck defending yourself from the bullies with the name B.O. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a quick break from the show so I can tell you a bit about our sponsor, NordVPN. And just quickly, what is a VPN? It's a virtual private network that protects you while you're online. It works on your PC, your notebook, your tablet, your mobile phone or cell phone, and even your smart TV. It's just a piece of software, but it's pretty powerful. Why do you need a good VPN? Pretty simple. It enables you to use the internet, no matter where you are, with total security by encrypting the data flow and maintaining your confidentiality. It's especially handy in places where you might be using public Wi-Fi or unsecure public network systems, and protects you from data breaches and scammers. But even at home, it adds a significant layer of protection and will warn you if you're visiting a questionable website or experience some kind of security issue. It's pretty cluey stuff. So which VPN do you need? The best one, of course, and that's NordVPN. Right now, they have extra discounts available for Black Friday, plus up to 4 extra months for free. So just go to the special Space Nuts URL, nordvpn.com/spacenuts, and click on Get the Deal to find out which package suits you. And don't forget all their other amazing services, including NordPass, which is my fave, where you can securely save all your usernames and passwords. And they back themselves with a 30-day money-back guarantee. The URL again, nordvpn.com/spacenuts. That's nordvpn.com/spacenuts. And then click on Get the Deal for a Black Friday exclusive deal as a Space Nuts listener. That's nordvpn.com/spacenuts. Check out all the details in our show notes. Now back to the show.
0G, and I feel fine.
Space Nuts.
Now, our next question, Fred. Sorry, Bo. Our next question, Fred, comes from Vincent. Photons are the force-carrying particle that mediates the electromagnetic force governing the behavior of things like magnetic fields. But they can also form into self-propagating electromagnetic fields, which we call light. If the hypothetical graviton were to exist, could it also form into analogous self-propagating graviton waves? What would those be? I say graviton waves to distinguish them from what we know as gravity waves under relativity, since I think they would be two different things. Or are they one and the same, Vincent? Good question.
It is a good question. I'm going to make a comment from Pedant's Corner here, Andrew, because gravity waves are things that happen in atmospheres. Gravitational waves, however, are the wobbling of space and time that we can detect. And yes, I told you it was from Pedant's Corner. I'm sorry about that. Apologies, Vincent. You know what I mean. So that's an interesting question. And what we're talking about here is, that nexus between quantum theory and relativity, because relativity is what determines gravity as a waveform, the gravitational waves, whereas quantum mechanics would be what would determine the behavior of gravitons. I don't actually think, though, that there is any need to distinguish the speed of gravitons, which is the same as the speed of photons, light, subatomic electromagnetic particles. I don't think there's any need to distinguish that from the speed of gravitational waves, which we know is also the speed of light. I do understand the direction that Vincent's coming from in terms of separating these, the analog between that electromagnetic force and the gravitational force, and the analog between photons and gravitons. Sadly, we don't actually know whether gravitons exist or not. The likelihood is that they do, but we have no theory for it. But that's interesting thinking, Vincent. I suspect the answer is no, that they are one and the same, as you've suggested.
Okay. Yeah, it's just one of those mysteries that we are yet to resolve. The particle physics, I suppose, is probably one of the most mysterious areas of space science, because we've been trying to we've been trying to capture things, we've been trying to study things, the Higgs boson, for example, and they make these little discoveries, but then they come up with so many different questions as to why and how and what they actually discovered. It's a little bit weird, to say the very least.
The weirdest thing I read recently, which comes from a quantum physicist, is a paper that suggests, and I think it was carried, there was an interview with this gentleman carried by New Scientist magazine. But this person who's at the one of the universities in Spain, he suggests that the laws of physics aren't really there. that there's something to do with subjective consciousness, and that is a really spooky idea. And he's a quantum physicist, so
yeah.
But I'm afraid. I think a lot of this goes into philosophy as well, sort of metaphysics and things. And some of the terminology, I'm afraid, lost me. I had to go to Wikipedia to look up several of the words that I was reading, and I didn't understand what Wikipedia said either.
No.
So
it sort of seems to occasionally cross into the realm of we live in a world that's actually just been created by a mass consciousness rather than being a physical reality.
Yeah. Well, I think that's where this argument was heading.
Yeah. Because there are some that actually think that's a thing that we've basically imagined ourselves into existence. That's way out there. There's a book in that somewhere, but I'm not writing it.
No.
Whack. Way too whack.
Yeah.
So what was the answer to Vincent's question? Dunno.
It was maybe,
probably.
Basically, I think it's the one in the same. Speed of gravitons is going to be the speed of gravitational waves.
Yeah, very good. Thanks. Excuse me. Thanks, Vincent.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
Our final question, sort of a questiony, statementy, weirdy thing, which is coming from Christopher.
Hello, gentlemen. My name is Christopher Ballou, contacting you all again from Fayetteville, North Carolina. And I just wanted to know if y'all had ever heard or read anything about the reasons there were floods. I think this was back in biblical times, but it was because the solar system had ejected a planet and it had whizzed by Earth, leaving like a snake-like serpent of light across the sky. I didn't know if y'all had heard anything about that or if I'm just having like a fever dream. But keep it up, guys. Love the show. And hey, may the force be with you.
Thank you, Christopher. And then I've got a terrible one-liner in response to Christopher. No way we're doing that.
Ta-da! Boom tish.
Boom tish, indeed. Hang on, I've got that sound effect, I think. I've got that sound effect. I can't remember what it's called, though. It's got a weird name. But, hang on, is this it? There it is.
Yeah, there you go. Love it. What's it called?
It's called Rim Shot.
Oh, there you go. Well, it is a rim shot. That's right.
Yeah, that's right. Look, you can draw some events in history to astronomy, like the Christmas star, which we've talked about in the past. And there was an anomaly, an astronomical anomaly around that time that is well documented. So, yeah, the question of whether or not these biblical floods that Christopher refers to could have been coincided with some sort of an astronomical event, probably not that big a stretch if you can get the timeline and the proof in
yes, I think that's right. I think you've got to look at these with an open mind in regard to whether they're describing something that happened, and there's a good chance that they were. I draw the line at the solar system ejecting a planet and serpent-like light across the sky. I think, though, so Christopher's question reminds me of a book written by two colleagues of mine at the Royal Observatory in Edinburgh. And sadly, I don't actually have a copy of that book. I used to have one because they wrote a nice dedication in it, but I lent it to somebody. It was called The Cosmic Serpent, and that's what Christopher was saying is what reminded me of it. And it's by Victor Klube and William Napier, two colleagues. In fact, Victor Klube was my boss. And as far as I know, Victor is still going strong, living in retirement in Bayeux in northern France, in a castle where we visited him about a decade ago. Anyway, The Cosmic Serpent was the book that these two gentlemen wrote in the wake of their discovery that the Earth has probably been bombarded by comets and asteroids. This was all at the end of the 1970s, and unfortunately, somebody else kind of picked up the kudos for that discovery. They did write a paper which was published in Nature magazine in 1979, I think, called A Theory of Terrestrial Catastrophism. And it was all about things that may well have hit the Earth, and how, not just wiping out the dinosaurs, which was the new idea at that time, and it was that caused the media stir, but that there may have been episodes in historical times that have caused catastrophes of one sort or another that may have accounted for things like the flood, to be ensconced in certainly initially in the folklore, but eventually in the Pentateuch, the books of Moses. So it was an interesting theory. I think things have probably moved on quite a lot since then, but these two were hard-nosed scientists, and they were prepared to look at a lot of the history of Earth in terms of how things like impacts from asteroids might have generated the kind of phenomena that we saw. So yeah, it's something that I think we as scientists need to be open-minded about. And it goes into other cultures as well. There's evidence that there was an impact, probably a large meteorite, which gave rise to some of the Dreamtime stories of our First Nations people here in Australia, certainly up in the Northern Territory. There are stories that tally with a potential impact about 10,000 years ago. You've got a culture here which goes back 60,000 years. So that culture is a living culture with a lot of verbal tradition in it, and that's how the phenomena like a catastrophic event like a meteorite hitting the ground could be preserved in the stories that they have, the Dreamtime stories.
Fascinating. Yeah. It just reminded me, Fred, this has got nothing to do with Christopher's question, but you were talking about ancient beliefs and ancient events, and not to dismiss them. But while we were in Turkey the other day, we visited the ruins of Ephesus. I don't know if you've heard of the city of Ephesus.
Yes.
Fascinating. Got to walk the original streets of Ephesus and saw the temple. And one of the things that I spotted there that was pointed out to us was the statuette of Artemis, the goddess of the moon.
Yep. Apollo's relation to Apollo. I can't remember which relation it was.
Yeah. So the statuette of Artemis is in Ephesus and still exists there today. A Roman statue made around 100 AD, I think.
Yep.
Which still sits on a plinth in the city of Ephesus in Turkey. Yeah. But you blink and you miss it. But it's there amongst all the ruins. But you can still see how the city existed and was laid out, and all the buildings. And one of the buildings that remains prominent and has still got quite a solid structure is the brothel. So, which is right near the road to the port, because the ocean used to actually reach where Ephesus is, no longer nearby because of the changes and earthquakes and things. But yeah, there was a road leading from the port into Ephesus, and one of the first buildings you come to is the brothel. So yes, but fascinating place. Yeah, really interesting place. There's so many interesting ruins in Europe and in Asia, and Turkey's no exception. Christopher, thanks for the question about biblical floods. Yeah, probably something somewhere has crossed paths with astronomy that or space science that's created that possibility. Indeed. And thanks to everyone who sent in questions. Don't forget, you can send in questions too. All you have to do is jump on our website, spacenutspodcast.com or spacenuts.io, and go to the AMA link where you can send us text or audio questions. If you've got a device with a microphone, that's all you need to send us an audio question. We'd love to hear from you. Don't forget to tell us who you are and where you're from. Fred, thanks as always for answering everybody's questions. Much appreciated.
And I appreciate being here too. Thanks, Andrew. Take care, and I hope that husky voice goes back to normal soon.
Hopefully, yes. And thanks to Hugh in the studio for not pestering us with questions. And from me, Andrew Dunkley, thanks for joining us. Hope you can join us again on the very next episode of Space Nuts. Until then, bye-bye.
It's one small step for man, one giant leap for mankind.
There you go. And when I find the outro, I'll hit it. And I again say, from me and Fred and you, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.